Hi guys, good morning. In this video, we're going to see the problem Scramble Strings. It is one of the awesome problem, not understanding the algorithm, but understanding the whole flow, especially the complexity of this problem. No one, mark my words, no one has explained how the complexity of this problem works and how we can find it. People have optimized it good for what reason, I don't know why, but yeah, now we will see this problem, the entire thing. And if you guys like it, then do the like button after, not yet. Let's see. It says that we can scramble a string S to get a string T. Word scramble is defined as how the length, if the length is one character, one letter, we can stop. If the length is more than one, we can do following. We can split at a random index, and what we can do is, when we split, it's a string, we split at a random index, we get a first half, let's name it as X, next half, let's name it as Y. So S can now become X plus Y. So the scramble of that string would nothing be X plus Y or a Y plus X. So basically what we can do is, if the length of a string is more than one, I can do the following operations. Split the string into two non-empty substrings at a random index and make it X and Y. Randomly decide to swap the two substrings or to keep them in the same order, which means I split it, got a X plus Y, either I can swap it, I can make them as same, X plus Y or Y plus X. Just understand it because it will help us very much later on. Apply step 1 recursively on each step of the two substrings X and Y. Apply the same step. Now X will again be broken into X1 plus X2. It can also be swapped as X1 plus X2, or we can also get a X2 plus X1. Again it can go on, again it can go on. So we can apply this step recursively as much as we want. Ultimately, what we need to find out is that two strings S1 and S2 of same length. So firstly, we like in the problem itself, it's written S1 and S2 of same length. So many people write the condition, if n is S1 dot length, then S2 dot length should also be n. If it is not, then return false. It's not required at all because it's specifically mentioned it's of same length. But we do return true if S2 is a scramble string of S1 or vice versa. Because see, if S2 can be transformed to S1, scrambling S2 can transform it to S1. So S1 also can transform it to S2. If you can't understand the statement right now, I'll explain you. But it's like that, okay. S2 scramble can, like, see, it's a word, ARYAN. If you scramble it and you like get something as ANARYA, so you can again scramble A and ARYA and again get back Aryan, right? So it's like, it's a cycle. You can get scramble of anything. So otherwise, if you cannot, if S1 and S2, which you have been allotted, if they are not scrambles of each other, then you have to return a false. I hope that you guys got the problem statement. Now let's see how we can see. S2 was, in this example, it was RGEAT. S1 was GREAT. As it is said, recursively find. So what I will do is, I will find every scramble of S1. I will find in my mind what I thought. The first thought is in my mind is, if S2 is a scramble of S1, right? So how come I find every scramble of S1 and see, oh, if S2 is matching or not? It is the first thought in my mind. I'll do the same thing. I'll go on and try finding every scramble of S1. S1, I just started. Okay, how to find the scramble? The first operation was split at a random index. I want to find every scramble. So I'll split at every index. I split at first, second, third, fourth. I can't go beyond because after that it will become like this after T, and after that you will get an empty substring, and it is said it should not be empty. Non-empty substrings. Right? Cool, no worries. Now, although you can go recursively, but I'll explain, but I'm showing. I am finding every scramble of S1. Cool, no worries. Then what I will do is that, okay, I have this particular split right here. So I will now have two options, X and Y. X is one thing, Y is one thing, right? So X and Y. Again, you remembered one thing. If we had X and Y, we can make it either as X plus Y or as Y plus X. So it is X plus Y or it is Y plus X, right? Just like this. Cool. Now again, I can apply the same operations. I can apply the split on this GR and on this EAT. As I want every possible solution of scramble, I'll just apply split on GR and get a GR, G plus R. I'll apply split at every E, I apply split, EA, I apply split. So I try to apply split at every point to get every scramble possible so that I can match. Okay, I'll find every scramble possible of S1, find if it is with S2 or not. If it is yes, then I'm good. So again, I just get a G plus R. Then I get a E plus AT because E split, so E and AT. Then EA split, so then EA and T. Then again at AT, again I get a AT. Then again I had a split at between AT. I get a, I get a T. So it is how I'm splitting. I'll show how I will actually get the scramble. So basically, if you split the AT, then back when you are moving back, so you split the AT. Now AT can be split as A plus T or T plus A, which means that when you are moving back with this AT, you can get a AT or a TA. It's just an example, but after this I'll exactly show that okay, how I am getting every scramble possible. But firstly, I'm showing okay right now how the scrambles are being made. Then again, for every, as I split it right here, right? So it was broken into GR plus EAT. So I just made scrambles for GR and EAT, and then after I will attach them where the subpart of GR is first and EAT is next. But I can also have a EAT plus GR, which means Y plus X. So again, I'll repeat the same thing for EAT and GR. And again, I can just go on for every of this particular. See, I just had this GRE and AT. I just had the GRE and AT, and I can also have AT plus GRE. If you closely see, GRE, AT and AT here, EAT. Isn't that if you do this recursively, you will just recompute the same thing again and again, because ultimately you want to find the scrambles of EAT, as if you want to find okay, what is the scrambles of EAT possible, right? And you are repeating the same task here, everywhere. TR is here, EAT is here, 180 is here, 180 is here, 180 is here, 180 is here. What's going on? Why you are doing such a repetitive task? As when repetitive task comes is our TP. We just store. Okay, if we have found a scramble, if this EAT, whatsoever scrambles can be possible of this EAT, I just found okay, EAT as a scramble I have found. What all possible scrambles of EAT are there? I'm just good. I don't have to go on again in this. With this, I can just not go on to every possible scramble again and again. Okay, now you got okay, how can you make the scrambles? But do you recognize how the scrambles was being made? I mean, you found okay, the scrambles was made, but when I just showed you how you go down in a tree, but when you are coming back, how the scrambles were being made. As in this picture I just showed you earlier, I just took one path only to actually show you how the scrambles were being made. So when you split your GR and EAT, you just again split your GR, EAT, EAT. Then your GR was split at G, split R, EAT was split at E, split AT, and also EAT was split at E, A, split T. Now to actually show how that GR was split as G and R. Now it's 1-1. So I can have G plus R or R plus G. G plus R or R plus G. It can go, see, as you can see, GR and RG. For EAT, again, I can have a EA plus T. Then EA again can be split as E plus A and A plus E. This again EA can be split as E plus A and A plus T. When I move back, I get a EA, AE. Here I get a EA, AE, same. Then here after it is T. So I'll get a EAT or AET. From here I'll get a TEA and TAE. From here, if I go on to upper, see, I get this 4 options from EAT, right? From this EAT, I get this 4 options. From this particular GR, I get this 2 options. So when I'm moving back from this GR and this EAT, what will happen is I'll get a GREAT, or I can have a GRAET, I can have a GRTEA, I can have a GRTAE, I can have a RGTEAT, and so on. You got what happened? Whatever was possible because of the left half and whatever was possible because of the right half, I just attached all of them to get all the possible, scrambles. It is how the scrambles were being made. Now you will just have one thing. You will just recursively find the scrambles. You know that the scrambles are repeating. Like I can have one string to form a scramble and it can be repeating at times. So I can just store, okay, what all scramble I have got and for what all strings I have got the scrambles of. I can store that, cool, no worries. And I know it's kind of repetitive, so I can just have a map or something to identify that I don't have to go at that particular string again and again. But you are sorted now, as of now. So you can just write the recursive function, store that particular string as a key in your map or something, and you are good to go to find and just ultimately see if you can find a scramble of S1 in S2, you are good. If you are not, then ultimately return a false. Cool. Do you know what's the complexity of this problem? It is the most tricky part. See how. It's the reason I just drew that diagram up till that one path to actually show you how it is. The first operation was to actually split at every position. So to actually split at every position, you were splitting it at here, then at here, then at here, then at here. So for that every split, O of n, right? Now, when you had that split, now the next option you had was to get, so now you have the split. Now, if you have, now because of the split, you only, because of this O of n, you get to know about the split position. But the split string, for that you have to get the left half string and the right half string. When I say string as a whole. So split position you get to know about O of n, but split string, which is now the string formed, are the split strings. So that split strings, to get that split strings, again a O of n will be applied. Got it? And it's also not to get the split strings. Let's say in next iteration I want to merge these two split strings back. So again I have to apply O of n. So it is kind of O of n for split also, O of n for merge also, plus O of n to analyze also if it is equal or not, which means S1 and S2 are equal or not. So it is all O of n, which means the operation on that split string is actually of this particular thing. I have also shown here also that this O of n is nothing but splitting plus merging plus computing, or like S1 and S2 comparing. So it is that particular O of n you get. For every split, you have to actually get those, why I don't know why I'm doing this, but you have to get those particular strings. Now you got that splits. Now what will happen is you got first half, okay, GR, then you got a EAT. You remember what happened? For this, you have got two recursive depths because it is just broken into two halves. Both GR and EAT will go n deep, which means that it can go n deep. It can go n deep. So left part recursively will go up till the depth of n. Right part can also go up till the depth of n. And ultimately, as I showed you, what I did was what all things I got from the left half, I just multiplied it with what all I got from the right half. It is nothing but n from here, I got n depth, I got some elements. from here I went to in-depth, I got some elements, and then I multiplied them to actually get all the possible scrambles of that string. So it is how we get a O of n square with this. So as we are moving it down, which means we have to do every operation. So n for split, then n for compute, and then n for n square for that particular parts of that string. So in total, it is O of n raised to power 4. I hope that you guys got it, because I explained very deeply upon how it is being done. So ultimately, we can also think of it as we have O of n cube strings in total, for which we have one operation. For every string, we have one operation as, like, we can just merge it or split it or actually analyze it. Analyze in sense, compare with the other string, which is S2. It is the reason that our space is also O of n cube, where the one operation which will not, because space is like nothing but how many strings are there, how many locations or how many storage is being occupied, and storage is being occupied only by the map which we will be store, in which we will store all these strings. And how many strings will be possible? Nothing but for every split I will get a GREAT, for every split then GRENAT, and then to analyze all these things I'll just move on to every of these particular left half and right half and multiply to get all these strings possible. So ultimately one split O of n square, n splits O of n square into n. Ultimately, I get a O of n cube number of strings which I have to store. But always make sure when you are trying to think, see, I just showed you, but ultimately we are storing it in a form of, see, I just showed you the complexity of this problem, right? But when you're trying to think about of this, and when you will just write down, you will just see, okay, it's not actually O of n square. It will be if in total every of these which will be made, because it is repeating this EAT and GR, it will be repeating in something else also. So in total it will have it as a O of n square, or you can think of it as, okay, I have one split, because see, if you split at G, then again as at this end point something would form which will be something like G and REAT. So in total you have to analyze that, okay, very slowly, maybe you can watch this again if you don't analyze, but in total you have to analyze that it is O of n raised to power 4, and how I showed you n for split, n to actually compute that, okay, if it's a left half, then we can have to split these strings to apply the operation on a string as a whole. Then again O of n for this left subtree and for this right subtree. Ultimately I have to get both of them, so it's n into n, and it's ultimately O of n raised to power 4. And spaces, as I showed you, the operation only for merge and split or the compare, it will not be applied. Ultimately I'm just getting O of n cube strings, n for every split and square for n square for every of that splitted left and right subtree. I hope that you guys got it. Let's quickly, okay, I just spent a lot of time in complexity, but it was the most important part of this problem because no one has explained this and I wanted you guys to understand it. Now the code is pretty simple. Everyone I showed you, I'll also show you. Base case, just get the size, just see, okay, if both the strings are equal at the front, which means it's a recursive function, right? So ultimately it just go on deep down. Here it's the reason I showed you, it's O of n for that comparing of strings, right? And ultimately if my n is 1 and my strings, because see, ultimately if I am at this point, which means I have compared S1 and S2, and S1 and S2 are both of n equal to 1. If it is at this point, and for sure I know, okay, my S1 and S2 was not equal, so which means that I had to return a false. It's just a base condition, pretty simple, pretty standard, you can just write it down. Then I have this key because ultimately I know if I get something as x plus y, so when I'm just having a recursive call, I just need to store down if I have found that particular combination or not. So I just stored it as S1 plus S2, and as it can be something as ARYAN. So AR and YAN, if it is as S1 and S2 are different, and ARY and AN is as an S1 and S2 are different, right? So I just have a space so that I can actually identify it's a different key and it's a different key, right? So I just had a space in this. Now ultimately I have this map which actually will let me know, okay, if I found it, you can just return a that particular value. If it is not, then I'm going to have every split. It is for every possible split. Now every possible split, I have two options. First option is that if, see, as I showed you in the example, when I was explaining, I showed you, okay, if you have S1, make out every possible scramble of S1 and compare with S2. Or you can do the same thing, that you can find every possible scramble of S2 and compare with S1. Right? So I am doing the same thing. S1 is nothing but, when you have this split, S1 is nothing but X plus Y. So its scramble would look nothing but X plus Y or Y plus X. So I will just make this X plus Y and Y plus X and will compare with my actual S1, which means that this X I will compare with this X, or it can happen this Y I will compare with this X. Sorry, this X I will compare with this X, or I'll compare this X with this X. Or I can do is I can compare this Y with this Y, or compare this Y with Y. S2 is here, S1 is here. I'm doing the same thing. If it is my S1, it is my S2. S1, which means I compared this particular part, which means the S1's first part, left part, I compared with S2's first part. And same, I just compared S1's right part with S2's right part. S1's right part with S2's right part. S1's left part with S1's left part. Here I compared S1's left part with S2's right part, S1's left part with S2's right part, and S1's right part with S2's left part, because ultimately it can be X plus Y or Y plus X. So I did the same thing. I kept my S1 as same. I just tried to scramble S2 and compare. Okay, scramble S2, it can be X plus Y, which means the same as my original S1, or it can be Y plus X. So better compare my S1 left part with S2's right part. And it is the same if it is, okay, if both are scrambled, because see here the GR and RG, ultimately I'm not comparing the strings, I'm comparing the scramblarity of that strings. So this S1's left part and S2's left part both are scrambled, so it will return a true, and S1's right part and S2's right part also both are scrambled, so it will return a true. And ultimately if it returns a true, so I'll just map, okay, my this particular key, which means my left was this, my right was this, it is a scramble and it is with this particular key. Here also you can see it is S1's right part and S2's, sorry, S1's left part and S2's right part. Here it is S1's right part and S2's left part. I can just again compare. If it is true, then it will just return a true, mark it as true, which means I've found a key and it's a scramble. Ultimately, if I don't find, which means S1 and S2 are not scrambles at all, my recursion will move back to the root, and ultimately root has nothing but S1 and S2, which are actually being compared as being scrambles or not. If it is not, then I have to return a false, and ultimately I am done. The codes, firstly, are like the codes for every problem, C++, Java, Python is there in the comments. In Leetcode, if you're trying to solve it, it will not be as efficient as possible, because the Leetcode codes, which means test cases, have a small bug in which if you optimize your code, and it's not the actual optimization, if you write this program in the actual another platform or something, or maybe in the actual interview, it's not a meaningful optimization at all. It's just that the optimization which is mentioned here is just a bug in the Leetcode test cases, because of which your runtime, it can improve drastically, but it's not in the real life. The complexity will remain exactly the same. And what is this optimization which people have found out, is that if you have two strings S1 and S2 and we're comparing if both of them are scrambles or not, so both of them equal number of characters, which means if I have one string as S1 as ARYANN, so other string it can't be as NARYAA, because N is 1 here and N is 2 here. So the frequency of characters, it should be same. It is one thing which people have found out, and because of this they have increased the runtime. I have not mentioned in my code, and it's of no use, because in interview you will not mention these things, because your complexity is not increasing because of this at all. So yeah, It is one thing which I need to mention, and ultimately you can find every code down below in the comment section, also in the description. I hope that you guys liked it. I spent a lot of time because of this, and yes, you can. Goodbye, take care, bye.